This is the Math 2 lesson summary video for the lesson entitled Radical Ideas. In Lesson 3, Radical Ideas, the purpose of this lesson is for students to become familiar with converting between exponential and radical representations of expressions, as well as using the rules of exponents to simplify exponential and radical expressions. So if you recall from Lesson 1 and Lesson 2 of this unit, we did review some properties of exponents. I have listed some of the properties of radicals and some of the properties of exponents again here. If you'd like to pause the video, you may do so at this time. So in Radical Ideas, Tia and Tehani are wondering which form, radical form or exponential form, are better to use when working with algebraic expressions. In the first part of Lesson 3, Tia says that she prefers radicals, and we are provided with 3 properties of radicals. For example, number 1 states that the nth root of a to the n power is equivalent to a. If you recall from Math 1, we know that's true because of the fact that when the index and the exponent are the same, essentially they cancel each other out and we're just left with a. In number 2, the nth root of a times b is equal to the nth root of a times the nth root of b. And in the third property of radicals, the nth root of a divided by b is equal to the nth root of a divided by the nth root of b. On the other hand, Tehani says she prefers exponents. Provided in your MVP booklet are the properties of exponents, which we began working with in Math 1, and we also started working with in Lesson 1 and 2 of this unit. So what's important about this lesson is comparing the difference between rewriting an expression in radical form to simplify it, and then rewriting an expression in exponential form to simplify it. So with Tia's method, we know that Tia prefers to work with radicals. So what we're going to do is we're going to take the square root of x cubed, and we're going to rewrite that using radicals. So using Tia's method, we have the square root of x cubed. If we're going to stick with radicals, then what Tia will do is x cubed. If we think about our properties of exponents, that would mean that I can rewrite that as x times x times x, because x times x times x is x cubed. If we go further on that, we know that we can rewrite that as the square root of x squared times the square root of x. And like we've just discussed in the previous example, the square root and the square will cancel, so we can simplify this to x root x. So that is Tia's method using radicals. So for Tehani's method, if you recall, Tehani prefers to use exponents. So what we're going to do is we are going to simplify the square root of x cubed, and we're going to rewrite that as x to the 3/2 power. And x to the 3/2 power is equivalent to x to the 2 over 2 plus 1/2, because 2 over 2 plus 1/2 is 3/2. And if we simplify 2 divided by 2, we get x to the first, and we can keep our base the same, x to the 1/2. So we're using our properties of exponents here. If we were to simplify that further, we can leave it just like that, or we can rewrite this as x times the square root of x, which yields us the same answer that Tia got when she used radicals. Okay, so let's look at the next one. The next one is the cube root of x to the 5th. So let's simplify that using radicals. So that would be the cube root of x written 5 times and then since our index is 3, it is a cube root, we can rewrite this as the cube root of x cubed, because we have 3 x's here, and we'll just rewrite that as x cubed times the cube root of x squared. Now, if we are to simplify that, if the index and the exponent are the same, they do cancel out. So we would simplify this to x times the cube root of x squared. And that is the simplest that we can go on that. So now let's work with Tehani again. Tehani prefers exponents. So if we were to rewrite the cube root of x to the 5th as an exponent, it would become x to the 5/3. And if we break down the fraction 5/3, we can rewrite that as x to the 3/3 plus 2/3. And we know with our properties of exponents that we add the exponents when the base is the same and we are multiplying. So I can rewrite that as x to the 3/3 times x to the 2/3. X to the 3/3 is equivalent to x to the 1st and then times x to the 2/3. And if we want to rewrite that, we can. That would be x times the cube root of x squared, which is the same answer that we got for Tia. So let's take a look at a more difficult problem. Let's look at this one here. So it's the cube root of xy to the 5th divided by x to the 7th, y squared. So the first thing I'd like to do is remember Tia prefers radicals. So we're going to simplify that using radicals. So we'll rewrite that as, I'm just going to rewrite the whole question, xy to the 5th power divided by x to the 7th, y squared. Okay, so let's rewrite the numerator and the denominator. I'm going to break up the numerator. I'm going to keep my cube root. I'm going to break up the numerator into, I see I have a y squared. I'm just going to highlight that for you. So you see if you have a y squared there. So what I'm going to do is I know there is going to be a y squared in y to the 5th. So I'm going to rewrite y to the 5th as y squared times y cubed. Because we know using properties of exponents that when we have the same base, we're going to add the exponents. In the denominator, I'm going to rewrite x to the 7th using x cubed, and an x. So let me just write that. It's giving me, there we go. And bring the y squared. So now what we see here is we can cancel out if there is a term in the numerator that will cancel out with the denominator. So y squared will be gone and the x's will be gone. So we can simplify this to the cube root of y cubed divided by x cubed times x cubed. Okay, now if we are to rewrite this, I'm going to write the cube root of y cubed in the numerator. And that will be divided by, just need to make sure I have enough room, the cube root of x cubed times the cube root of x cubed. All right, so what ends up happening there is my index is 3 and so is my exponent. So those will cancel. In the numerator, I'm going to have a y. In the denominator, same thing will happen. The index will cancel with the exponent, so you'll be left with x times x. So if we are to simplify that, that would end up being y over x squared as my final answer. Okay, so we're going to do the same thing with Tehani's method, which is using exponents. If you notice, the index here was 3. It was a cube root. So I'm going to take everything that's under the cube root and I'm going to raise it to the 1/3 power. So it becomes x times, and I'm going to change y to the 5th to y cubed times y squared because I see I have a y squared in the denominator, and that is divided by x cubed times x cubed times x times y squared, and that is all raised to the 1/3 power. So before I raise that to the 1/3 power, I am going to cancel out the terms that I can cancel out, just like we did in the previous example. So I will be left with y cubed divided by x cubed times x cubed, and that whole quantity will still be raised to the 1/3 power. Properties of exponents tell us that we have to give the exponent to both the numerator and the denominator. So I'm going to give that exponent to the 3, and I'm going to give that exponent to both of the exponents in the denominator. So this would become y cubed to the 1/3 power divided by x cubed to the 1/3 power times x cubed to the 1/3 power. And when we multiply that, we know that 3 times 1/3, because that's property of exponent, when we multiply this 3 here times the 1/3, we're just left with a y. When I do the same thing here, 3 times 1/3, I'm just left with an x, and 3 times 1/3, an x. So my answer simplifies to y divided by x squared. So the next part of this lesson showed us equations that were both solved in different ways by Tia and Tehani. Tia still prefers to use radicals when she is simplifying, and Tehani still prefers to use exponents. So what we're going to do is we're going to take a look at this equation and we're going to try and solve it to get x by itself, and we're going to use each of those methods. So let's go over Tia's method. Tia's method, she prefers radicals. So to change x minus 2, the quantity squared, to a radical, we would rewrite that as the quantity x minus 2 squared. Just going to rewrite it. And we would take the square root of both sides, because when we square root a square, they cancel out. So these two would cancel, and we would be left with x minus 2 equals root 50. And how we can get x by itself is we can add 2, and x would become 2 plus root 50. If you recall from Math 1, you might know how to simplify the square root of 50. I'll go through that here on the video. But 2 plus the square root of 50 can be broken down into the square root of 25 times the square root of 2, and the square root of 25 is 5. So 5 root 2 is how we can rewrite the square root of 50. So notice that the answer is left with a radical. Now let's try and do the same thing with Tehani, except we're going to change and simplify this equation using exponents. So I'm going to rewrite my initial equation, and we are going to raise the left and the right side to the 1/2 power. So what we have here then is going to be x minus 2 quantity squared, let me use brackets, to the 1/2 power, and then we have 50 to the 1/2 power. On the left, what happens is the 2 times 1/2, remember power to power you multiply, so 2 over 2 is just 1. So those will cancel out because we'll be left with 1. So we're initially going to be left with x minus 2. And then we have 50 to the 1/2 power. The next thing we're going to do here is add that 2. So we're going to add that 2 to both sides, and we'll be left with 2. And that's plus 50 to the 1/2 power. I'm going to rewrite 50 as 25 times 2, or as 5 squared, because that's 25 times 2 to the 1/2. And if we multiply that 1/2 times that 2, we're just going to be left with 2 plus 5, and then rewriting 2 to the 1/2 will be square root of 2. So you notice here that we have the same answer as we have above. So in the last part of this lesson, Zach says to use the graphing calculator to help visually represent the solution that they obtained. So what they did or what Zach is proposing, is in your y equals, we type in the left side of the equation, the quantity x minus 2 squared, and in y2, we type in the right side, which in the first equation was 50. If we graph both of those equations, we should see that one is a parabola and one is a line. Now the solutions to these equations should be where the parabola and the line intersect. So we notice that we have a solution here, and we have a solution here. So we actually have two solutions. But when we got our answer came out to be x equals 2 plus 5 root 2. So to check that value in my calculator, I already typed that in, and I saw that 2 plus 5 root 2, and I'll just erase those dots so you can see that. 2 plus 5 root 2 is approximately 9.07. But if I also performed 2 minus 5 root 2, I get negative 5.07. If I go back to my graph, you notice that the point on the right looks like the x value is approximately 9 point something. And the value on the left, negative 1, 2, 3, 4, 5, definitely looks like it's about negative 5 point something on the left. So what we're going to do here is, now that we've realized that there are actually two solutions, whenever we take the square root of a number, we have both the positive and negative solution. So for the first example, that would be 2 plus 5 root 2, and x is also 2 minus 5 root 2. If you need more help on the Ready, Set, Go for this task, please check the Canvas Student Support site.